So guys, what we're doing today is, again, nothing new. There's a little bit of stuff that we've talked about in Algebra 2, but didn't do a whole lot with. And that's finding a polynomial with zeros that are the following, that are given to us. All that's saying is that for this given polynomial, that x equals 0, x is equal to 7, x is equal to -3, with a multiplicity of 3, that's just saying that we have it 3 times, and x is equal to -9. These are all the values of x that will make the function equal 0. And what they want us to do is to find said polynomial. So the first thing we would do after this setup is to get all of these equal to 0. Well, luckily the first one is already there. So for the next one, what we're going to do is subtract 7 from both sides, telling us x minus 7 is equal to 0. Here, we're going to add 3 to both sides, telling us x is equal to x plus 3 is equal to 0. Well, we're going to do it 2 more times, incidentally. And lastly, we would add 9. Questions on this so far? Now, we talked about solving. We would normally take the function, factor it into multiple sets of parentheses, and then set each one of those equal to 0, because the zero product property. But this time we're going the other way around. Now we're going to take all of these, so x, and multiply them by each one of these here. Plus 3, x plus 3, plus 3, times x plus 9. And now we're going to simplify this. That actually is the final answer. We're not going to have to multiply this whole thing out. Because if we did, this would get absolutely massive. Because we're talking about, so 1, 2, 3, so 1, 4, 5, 6, x to the 6th. So we'd have 7 different terms we're looking at. So it'd be quite a massive function. And even on the homework, this is all it's looking for. That is the polynomial. It doesn't want us, or it's not going to make us multiply it out. We did multiply it out in Algebra 2 when we looked at these, but that's it. That is the final answer. Questions on this here? Because I wanted to look at least one of these. These aren't that bad. It's just telling us the zeros. So set x equal to each one of these numbers here, and if it has a multiplicity, we do it more than once. Get them all equal to 0, multiply them together, and that's it. Now, the other thing we're looking at is long division and synthetic division. Long division, synthetic division. Now, when we set long division up, we start off with the, I think some call it a house, some call it a garage, but we have this here. Our first part of our division, this goes inside. And we want to put it in standard form. Biggest exponent first, constant term last. And if there are any terms missing, we have to fill them in with 0 times whatever that variable is. So 3x to the fourth is the biggest one. It goes first. The next one would be x cubed. So we have plus 2x cubed. Then our next term would be squared. So we have plus 4x squared. Then we'd have x to the first plus x. And our constant term minus 5. And then we'll put what we're dividing it by outside. And again, if there are any terms missing, we have to fill them in with 0 times that amount. So our biggest variable is x squared. The next one after that would be x. And since we don't have an x term here, we fill it in as 0x. Then we have our constant term 2. Now this is set up. Now to do our division, this long division, we want to go term by term, canceling the first term inside out. So the first term that we have is 3x to the fourth. And we want to say, or kind of to ask ourselves, what times x squared will give us 3x to the fourth? Well, we're going to need a 3. Because 3 times 1 would give us 3. And then we need to see what times x squared would give us x to the fourth. And that would be x squared. Because 3x squared times x squared will give us 3x to the fourth. Now off to the side, you can do this here. 3x squared times our x squared plus 0x plus 2. 3x squared times x squared is 3x to the fourth, which is exactly what we wanted because we want that first term to cancel. Now 3x squared times 0x, well 3 times 0 is 0. X squared times x is x to the third. Plus 3x squared times 2 is 6x squared. Now we're still going to leave it in as 0x cubed because we still need something to hold that place when we're subtracting. Now we take this here and put it underneath. So we have 3x to the fourth plus 0x cubed plus 6x squared. And then we subtract. So our first one, 3x to the fourth minus 3x to the fourth. This first term, each time we do this, should cancel out. It should become 0. Now the next one we have is 2x cubed minus 0x cubed. Well, it's going to be 2x cubed. 4x squared minus 6x squared is going to be negative 2x squared. Any questions on this so far? Next part of this process is we bring down the next term, our negative 5. And we repeat the process again. How did I lose the plus x? This should be plus x minus 5. Okay. Say, I feel like I wrote that down. Weird. So, our next step is, again, repeating this process. What times x squared gives us 2x cubed? Well, what would that be? Plus 2x. And we can do this again. We'll do 2x times our x squared plus 0x plus 2. And we'll distribute through. 2x times x squared is going to be 2x cubed. 2x times 0x is going to be plus 0x squared. And 2x times 2 is 4x. And we'll put this underneath. 2x cubed plus 0x squared plus 4x. And once we get this set up, we're going to subtract again. Well, 2x cubed minus 2x cubed is indeed 0. Then we can continue on. Negative 2x squared minus 0x squared is negative 2x squared. X minus 4x is minus 3x. Now we finally bring down the negative 5. Any questions on this here? Now, last but not least, as we're down to the end, we're seeing what times x squared is negative 2x squared. What would that be? Well, it would be negative 2. We're going to multiply x squared plus 0x plus 2 by our negative 2. Negative 2 times x squared is going to be negative 2x squared, which is indeed what we wanted. Negative 2 times 0x is going to be plus 0x. And negative 2 times 2 is going to be negative 4. So we have negative 2x squared plus 0x minus 4. Now, negative 2x squared minus negative 2x squared is going to be 0. Negative 2 minus negative 2 is the same as negative 2 plus 2, which is indeed 0. Negative 3x minus 0x is, well, negative 3x. Negative 5 minus negative 4. Negative negative does make a positive, so negative 5 plus 4 is negative 1. So this is the whole part of our division, and the negative 3x minus 1 is our remainder. So if we wanted to write it as a whole expression, we would take the two and put them together. We would say that this is 3x squared plus 2x minus 2 plus our negative 3x minus 1 over what we were dividing it by, which was x squared plus 2. So if we want to write it as one whole expression, we would write it as this here, with our remainder added in. What we have left over divided by what we were dividing the whole thing by. However, some of the homework will just ask for the two separately. The quotient, if I'm remembering correct, which would be our 3x squared plus 2x minus 2, and then it'll ask for the remainder. And when it asks for the remainder, it's just looking for this here, the negative 3x minus 1, is what it's looking for. Questions on any of this here? Now, if it does divide evenly, we would get a remainder of 0. Questions on any of this here? So hopefully you do remember doing long division. It's been a while, because it's been over a year, most likely. For some others, it's been just a few months. Now, the other type of division that we had was synthetic division. Synthetic division, I believe, was one of the ones that y'all liked more than long division. It's a little bit simpler and a little bit easier. The first thing we needed to do was solve this here, what we're dividing by, x minus 4. Now, one of the main things is that the number in front of x, the term with the biggest exponent, had to be 1. If it wasn't, we divided the entire thing by it. Here it is 1, so we can just set it equal to 0 and solve. And it just tells us x is equal to 4. And once we do that, we can now set the problem up. So I call it, we make our little cubby hole and our line. The number that goes inside the cubbyhole is what we just solved for x. So it would be 4. The numbers that go across the top are our coefficients of what's being divided in order of descending exponents. So the biggest exponent we have here is x to the third, and its coefficient is 2. So we have 2 for x to the third. X squared would be next, so it is negative 10. Then we would have x to the first, or just x, and that variable is not listed, so we have to fill it in with a 0. Any of them that are missing have to be filled in with a 0. And then we would have our constant term. The number of terms that we should have is going to be one more than the degree, especially when what we're filling in here. So the degree is 3, so we should have 4 terms, because we have the 3 variables in our constant. So we do have 4, so they are all there. Our first step in synthetic division is to bring the first number down. So 2. Our next step is to multiply. We do 4 times 2, which is 8. And we put it under the next number. At this point here, we add straight down. So negative 10 plus 8. Negative 10 plus 8 is negative 2. We repeat the process. We now do 4 times negative 2. And 4 times negative 2 is negative 8. Add straight down. 0 plus negative 8 is negative 8. And lastly, 4 times negative 8 is negative 32. And negative 5 plus negative 32 is negative 37. Any questions on how we did this here? So I always put a box around the last number because this negative 37 is our remainder. Negative 37 is our remainder. The number next to it, negative 8, is our constant term. The number next to it is our term with x to the first. And then we have x squared. So our final solution for this here is x squared minus 2x minus 8. Plus, we add the remainder in, which is going to be 37 over what we were dividing it by, which is x minus 4. And that there would be the final answer. Now, whenever we divide, I didn't say this on the last one, but I should have. Whenever we divide, the degree of these two here are being subtracted when we get our final answer. So the degree of what we're dividing is 3. What we're dividing it by is 1. 3 minus 1 is, if we look at our answer that we got, the degree of it is, indeed, 2. Yes? If we look at the last one, over to 4 and 2, well, 4 minus 2 is indeed, is the degree of our answer 2? Yeah. It's a good way to check to make sure that it does work. And it will simplify it like that every single time. Any questions on any of this here? We feel pretty good with this so far. Yes? All right. We could do another one of these here with synthetic division. So this here does not have a 1 in front of it. It has a 1 in front of x, so we're good. So we set it equal to 0 and solve. And yes, we really could have just flipped the sign and been just fine too, because that's what we end up getting. We can set it up and put our number in the cubbyhole. So here it's going to be 3. Now for our coefficients going across the top, 4x to the third. X to the third is our biggest variable, or a variable with the biggest exponent. So our first coefficient, first number, is going to be 4. X squared would be next, but we don't have an x squared term, so it's going to be 0. X to the first would be the next one, so negative 28. And then negative 7. Now the first thing we would do is multiply, so we do 3 times 4, and 3 times 4 is 12. Add straight down, 0 plus 12 is, well, still 12. 3 times 12 is 36. Negative 28 plus 36 is 8. 3 times 8 is 24. And negative 7 plus 24 is 17. So the 17 would be our remainder. 8 would be our constant term. 12 would be our term with x, and 4 would be our term with x squared, giving us 4x squared plus 12x plus 8 plus our 17 over x minus 3. Any questions over any of this here? Do we feel comfortable with synthetic division? I want to look at this one with synthetic division. We can look at it in both, but I specifically want to look at it with synthetic division. Because the main difference between this one and the ones we've been doing is that the number in front of x is a 3. And because it's a 3, for us to use synthetic division, we have to divide everything by 3, which will give us the new equation of 2x cubed minus 5/3 x squared minus 1 divided by x plus 2/3. Now the rest of the steps are going to be very similar to what we did before. So we're going to solve to get the number that goes inside the cubbyhole, so our negative 2/3. Now we need the numbers going across the top. So x to the third is the variable with the biggest exponent. So our first number is 2. X squared would be next, so negative 5/3. Then we would need our x term, but we don't have one, so it is 0. And even though we didn't divide it by 3, well, 0 divided by 3 is still 0, so that doesn't change. And then our constant term is negative 1. Now we do have every single term. Since the degree of what we have here is 3, it should have 4 terms. We do have 4 terms. The rest of the steps stay the same. So the first step is going to be to bring down the 2. Now we multiply negative 2/3 times 2, which is negative 4/3. Now we are going to add straight down. What is negative 5/3 plus negative 4/3? Did we know? Negative 3. Because negative 5 plus negative 4 is negative 9, and negative 9 over 3 is negative 3. Now we multiply again. Negative 2/3 times 3 is, incidentally, negative 2. 3 and 3 would simplify, leaving us with negative 2. 0 plus negative 2 is negative 2. Now we multiply again. Negative 2/3 times negative 2 is 4/3. And lastly, negative 1 plus 4/3 is 1/3. So 1/3 is almost our remainder. We still have to do something with it. But negative 2 is our constant term. Negative 3 is our term with x, and 2 is our term with x squared. Now off to the side, I'm going to write this here. So our remainder would be 1/3 over x plus 2/3, because that's what we're dividing everything by, yes? However, we can't leave it like this because we do have a fraction in a fraction, yes? What did we divide the whole thing by to start with? 3, yes? We're going to multiply top and bottom of this by 3. Because if we do this, 3 times 1/3 is, well, just 1, yes? Now 3 times x is going to be 3x, plus 3 times 2/3 is just 2. Well, the denominator, 3x plus 2, is that what we started with? Yeah. So really, I'm just taking whatever I divided the whole equation by to start with and multiplying it by just the remainder to get it to fix out. So here, our remainder is really just 1. So if we wrote this back out, we'd have 2x squared minus 3x minus 2 plus 1 over 3x plus 2. And that's it there. Now, even if the remainder worked out to be a nice whole number, an integer, positive or negative, we still need to multiply it by what we divided the whole equation by. Because even if this here had been a whole number, that one's still not. So we'd had to do it anyways. Does that make sense? And it seems like a very odd thing to do, but it's a lot of this dividing is dealing with this right here. Because no matter what the number in front of x was that we're dividing it by, that first number always drops. It's always going to be the same. Now, if we did this by long division, this here, well, our first thing would be to say what times 3x is 3x cubed. Well, it'd be 2x squared, because what times 3 is 6? 2. X squared times x would give us x to the third. A shortcut I sometimes use is how many terms do we have here? 2, yes? I go over 2. 1, 2. That's going to be my first variable. The next one should be x, and the one after that should be the constant. They're going to follow in that pattern. Now we can multiply this out. 2x squared times 3x plus 2, which would give us 6x cubed plus 4x squared. And then we would subtract. These would indeed cancel. Negative 5x squared minus 4x squared is negative 9x squared. Bring down the plus x. Y'all see how if we hadn't divided the whole thing by 3, the first number that would have dropped would have been the 6, which had given us the wrong first term. And y'all kind of see how that works. So a lot of times, especially if there is a first term, a number in front of it, it's a lot easier to do this with long division sometimes. And especially if it's squared, it makes it a lot easier to work with. Now the next one would be to say what times 3x is negative 9x squared. Well, negative 3 times 3 is negative 9. X times x is x squared. So now we multiply 3x plus 2 by negative 3x, which would indeed give us negative 9x squared minus 6x. And again, we would subtract. These two would cancel. X plus negative 6x, or x minus negative 6, same as x plus 6x, which would be 7x. Did that right? Yep. That's not nice. Oh. It has been one little thing after another. It should be 0x. I was wondering why that went weird. It is possible to have those kind of deals where they're not nice numbers, but we are going to avoid those here. We're not going to make y'all do those, because those would just make the numbers even more funkier than they actually are. Because the last thing is, what times 3x is 6x? Plus 2. So we'd have 6x plus 4. Yep. Make sure I didn't mess this up anymore. That's not what we'd want. Because 6x minus 6x would cancel. That'd give us negative 7. So we'd have plus negative 7 over 3x plus 2. I don't like that, but I'm going to figure it out here in a second. Questions on this here? Because I have a feeling there was a sign change on the last one. I messed up. That's it. It's going to take a minute. Negative 2 instead of positive. Okay, that's interesting. Move that back. So 2, negative. Yes, I see. Because that should have been, now it decides to do that. Negative, positive. Yep. So that should have been positive. We should have made that negative, which would have given us negative. Thank you. Gosh, those are frustrating. Well, at least that should be somewhat comforting for y'all. That's not just y'all that do the same little sign errors. Yep. Questions on this here? So they are about the same. It's just one works out a little bit nicer than the other. Questions on any of this here? Besides the funky sign change that threw everything off. So are we good with this here? Now that I fixed that there. Now, if a polynomial f of x is divided by x minus c, then the remainder is f of c. Note the remainder theorem tells us that the value of f of c is the same as the remainder we get from dividing it by it. So if we were to plug the value into f of x into the function, the remainder of what it will actually equal will be the same as the remainder by dividing. So doing this, so with a, what we're saying is I can divide the whole thing by 2. So we'd have 1 for x to the 4th, 6 for x to the 3rd, negative 12 for x squared, negative 30 for x, and 35. So if we divide this by 2, or essentially we're saying x equals 2, or we're saying we're using long division, divide the function by x minus 2. Let's see what we get. 2 times 1 would be 2. 6 plus 2 is 8. 2 times 8 is 16. Negative 12 plus 16 is 4. 2 times 4 is 8. Negative 30 plus 8 is negative 22. 2 times negative 22 is negative 44. And lastly, negative 44 plus 5 is negative 9. So if we evaluated this function for 2, we would actually get a value of negative 9. Questions on this here? We can do the exact same thing for negative 7. Negative 7 times 1 is negative 7. 6 plus negative 7 is negative 1. Negative 7 times negative 1 is going to be positive 7. Negative 12 plus positive 7 is going to be negative 5. Negative 7 times negative 5 is going to be positive 35. Negative 30 plus 35 is positive 5. 7 times negative 5 is negative 35. So the value for this here is 0. And that is it for that there. Any questions on this here? Now, interestingly enough, okay, I kind of got these out of order. So factor theorem states if we plug it in or do the division and we get a value of 0, it's actually a factor. It's divisible by it. It's actually one of the solutions for it. If f of x minus c is a factor of fx, then f of c is 0. So as we saw with this here with negative 7 is actually a solution for this here. Or we can say that x plus 7 is a factor, because we'd have x equals negative 7, add it over. So that would be a factor of it. We're going to have to stop here because we don't have time to look at these here. We'll pick this up tomorrow.